All right, everybody, welcome back for another deep dive. You know how much we love to geek out about space here, right?
Definitely.
And a lot of you have been sending in articles about this telescope project called ExTrA.
Uh-huh.
ExTrA.
Yeah.
Yeah, so we're gonna dive into that today, and specifically how it's searching for planets that might be able to support life.
Sounds good.
So what's really cool about ExTrA, and this is something that jumped out at me right away, is it's not this massive, super expensive one-off observatory.
Right.
It's actually 3 telescopes working together.
Yeah. It's 3 telescopes, and they're all located at the European Southern Observatory's Silla Observatory in Chile.
Chile. Man, that's a great place for astronomy.
It's pretty much astronomy central. Yeah.
So how do these telescopes actually find planets? I mean, we're talking about things that are unbelievably far away, right?
Yeah. Well, it's ExTrA uses this really cool technique called the transit method.
Okay.
So you can imagine like a planet passing in front of its star.
Like a tiny eclipse.
Exactly. Yeah, like a tiny little eclipse. And when that happens, the star's light dims just a little bit.
Oh, so it's subtle.
Yeah, it's very subtle. But ExTrA can actually detect that.
Wow. That's pretty amazing.
Yeah.
So, okay, it makes sense that they can detect planets that way, but what makes ExTrA special? Are there other telescopes out there, doing the transit method already?
Oh, for sure. But ExTrA is focusing on a very specific type of star called red dwarfs.
Red dwarfs, okay.
And these are stars that are smaller and cooler than our sun, which is actually really helpful.
Oh, so?
Well, because they're dimmer, the dimming effect that happens when a planet passes in front is actually much more noticeable.
Oh, okay, so it's all about maximizing the contrast.
Yeah, exactly. It makes it easier to spot those planets.
I see. So we're finding these planets, but it's not just about saying, hey, look, there's a planet there, right? ExTrA can actually tell us something about the atmospheres of these planets. How does that work?
You got it. It uses a technique called spectroscopy.
Okay.
And basically, it looks at the light that passes through a planet's atmosphere. And different gases absorb different wavelengths of light. So by analyzing that light, we can figure out what the atmosphere is made up of.
Oh, wow. That's pretty incredible. So we're doing atmospheric analysis from trillions and trillions of miles away.
Pretty much, yeah.
It's amazing. So, okay, we find these planets, we analyze their atmospheres. What happens next? Like, what if they find some really promising candidates, planets that really could be like an Earth 2.0?
Well, if ExTrA finds a really interesting candidate, it's kind of like they get called up to the major leagues.
Uh-huh.
So the data gets sent to much more powerful telescopes, like the Very Large Telescope, or even the future extremely large telescope.
Yeah, those are some serious heavy hitters in the telescope world.
Absolutely. And those telescopes can give us a much more detailed look at these planets and might even be able to tell us if they have the right conditions for life.
Wow. So this small but mighty telescope project is really, doing some important work, finding the best possible places to look for life out there. It's crazy to think we might be close to finding another planet that could support life.
I know, it's so exciting.
It really is. And one thing I was thinking about is these red dwarf stars, they live for a really long time.
Oh yeah, they have incredibly long lifespans.
So if there's life on a planet around a red dwarf star, it's had a ton of time to evolve.
That's a great point.
Yeah. So much to think about with this.
Yeah.
So thank you for walking us through all this. I think ExTrA is a really fascinating project, and it seems like a really big step forward in the search for, are we alone out there?
Well, and that brings up a whole other set of questions, right? If we do find evidence of life beyond Earth, how does that change our understanding of our place in the universe? How do we approach contact? Do we even try?
Wow. Yeah, those are sort of some huge questions that we might actually have to grapple with in our lifetimes. Pretty wild stuff. All right, everybody, thanks for joining us for another deep dive. Keep those questions coming. We'll be back soon to explore more of the universe's mysteries.